Pure Maths 1, October, November 2024, Variant 3, question number 8 to question number 11. Let's go into question number 8. 8a, express 3x squared minus 12x plus 14 into the vertex form where a, b, and c to be formed. So for this, you have two ways to do. One, you can use directly your calculator or you can use your formula. But here I will show you the full completing the square method in order to transform the general form into the vertex form. Okay. So to do the completing the square method, so first we make the a as a 1. So we factorize the 3 outside. We factorize the 3 outside. So 3 x squared minus 4x. I only factorize for a and b only. For c, I don't do that. Okay, so it's going to be 3x squared minus 4x plus negative 2 square minus negative 2 square plus 14. So 3 x minus 2 square minus 4 plus 14. Therefore, 3 x minus 2 square minus 12 plus 14. So 3x minus 2 square plus 2. So your a is negative 2, your b is positive 2. Okay. For b, find this given that this function defined for x more than k. Find the least value of k for the f inverse axis. Okay, in order for your f inverse axis, it must be 1 to 1 function. Okay, so this is a quadratic and your a is positive, so this will be the basic shape of the thing where this point will be 2 2. I took from here. Okay, so I just take from here 2 2. That's a turning point. So they said if they want the f inverse axis, so it must be 1 to 1. So normally we'll take your axis of symmetry as the limit. Okay, it's either your x must be smaller or equivalent to 2, or your x must be larger or equivalent to 2. Then only it is a 1 to 1 function. So here they ask for the more than k, therefore your k value will be 2. Okay, for the rest of this equation you should assume the k as found in b. So means we are using the k value as this, so we're going to find the you're going to find the f inverse. So we already convert the fx in term of a vertex form, so we just rewrite that fx is equivalent to 3x minus 2 square plus 2. Okay, so in order to find the inverse function, we let our fx equivalent to y. So 3x minus 2 square plus 2 equivalent to y. Therefore, x minus 2 square is equivalent to y minus 2 over 3. Therefore, x minus 2 will be plus minus set y minus 2 over 3. So your x will be 2 plus minus third y minus 2 over 3. Okay, for converting it into inverse, everyone have their own method. So this is my idea. So usually I will let the function equivalent to y and I make the x as a subject. Then that will be my inverse function. So my inverse function of x is going to be 2. Okay, for plus minus, I just put here first plus minus. Set set x minus 2 over 3. Okay, so whether it's either going to be plus or minus only, it cannot be both. So we go back to this. So just now the graph is divided into two, before the axis of symmetry and after the axis of symmetry. If my domain here is less than equivalent to 2, is this region where it is negative, where it is after 2 will be positive. Since our graph is this region, correct, because it is x more than k, x more than 2, so we only have this part only. This part is not exist anymore already, so this part is no more exist based on the our domain here. So our answer here is going to be only positive, no more negative. Okay, so you remember your final answer, you only can have either positive or negative, and it totally depends on the domain that you chosen. Okay, hence or otherwise, solve f f x equivalent to 29. So since here they ask for f f 29, okay, so what we can do here, and the question specifically mentioned hence or otherwise, this shows that we need to use our answer from the previous one. So from here I can say it, f f x equal to 29. So I add f inverse. So f inverse f x equal to f inverse 29. So which is going to be fx will be x. So it's going to be fx equal to f inverse 29. Therefore, f inverse 29 will be, we can directly compute from here. So f inverse 29 is equivalent to 2 plus cert 29 minus 2 over 3. Minus 2 over 3. So it will be 29 minus 2 divided 3. Answer plus 2, 5. So 5. So fx equivalent to 5. Okay. So it's going to be, my fx is actually 3 x minus 2 square plus 2 equivalent to 5. Okay, therefore 3 x minus 2 square equivalent to 3, so x minus 2 square equivalent to 1. Therefore x minus 2, when you bring the square to other side, it must be plus minus 1, where x minus 2 equivalent to 1 and x minus 2 equal to negative 1. So x equivalent to 3, x equivalent to 1. And also remember, here just now you have x more than k, which is x is more than 2. Since your x is more than 2, more equal to 2, therefore your final answer only x equal to 3. So we reject this. Okay, please take note. You have to compare with the domain given also. Okay, now let's go to question number 9. The diagram shows the curve with the equation x cubed minus 3x plus 3 and y equal to 2x cubed. And find the x coordinate of the point of intersection. So in order to find the point of intersection, we can just equate the two lines. We just equate these two lines, where it's going to be 2x cubed minus 4x squared plus 3 equivalent to x cubed minus 3x plus 3. So we rearrange, so it's going to be x cubed minus 4x squared plus 3x equivalent to 0. So x squared minus 4x plus 3 equivalent to 0. So x minus 3 x minus 1 equal to 0. Therefore, your x equal to 0, your x equal to 3, and your x equal to 1. There are 3 points. So you can see x equal to 0 is here. So we don't need this fella. Okay, find the x of this point of intersection. So this is x equal to 1, and here is x equal to 3. Okay, they only ask for the x coordinate. So that's it. Okay. Find the area of shaded region. So area of shaded region is actually between 1 and 3. Why is wrong? And 3. So this is the area of shaded region. So this part. So what we can do is actually um, so the top curve minus the bottom curve and integral from 1 to 3. So it's going to be integral from 1 to 3, and the top curve is x cubed minus 3x plus 3 minus the bottom curve will be this 2x cubed 2x cubed minus 4x squared plus 3 dx. Therefore, integral 1 to 3. So x cubed minus 2x cubed is negative x cubed, and then plus 4x squared minus 3x positive 0, so it's dx. So you integrate this will be negative x power of 4 over 4 plus 2x cubed over 3 minus 3x squared over 2 from 1 to 3. So sub in negative 3 power of 4 over 4 plus 2 3 power of 3 over 3 minus 3 power of 2 over 2 minus negative 1 power of 4 over 4 plus 2 1 power of 3 over 3 minus 3 1 square over 2. So you compute this, you'll get 9 over 4 minus negative 5 over 12. So you'll get 8 over 3. Okay? Let's move on to the next question, question number 10. Point A, B have coordinate 4, 3, 8, negative 5 respectively with the circle radius 10 to the point A and B. Okay, show that the center of circle lies on the equation. Okay, we just randomly draw a circle. Okay, so this is your radius. Okay, they said A and B falls on this. Okay, so let's say here is your A, here is your B. So this is the AB line. Okay, and they said the center of circle pass through. So what we can do, this we try to calculate this line. Okay, we try to calculate this line. So it will be perpendicular bisector of AB. Okay, this line, maybe I just draw it. I use different color. So we try to find this one, which is a perpendicular bisector of AB. So first we find the midpoint of AB. Midpoint of AB, so will be 4 plus 8 over 2, 3 minus 5 over 2. So will be 6 negative 1, and then we find the gradient of AB. It will be 3 plus 5 over 4 minus 8, so which will be negative 2. Okay, so perpendicular bisector is a perpendicular, so negative 2 multiply the gradient of the perpendicular line will be negative 1, therefore m equal to 1 over 2. Okay, so y equal to 1 over 2 x plus c. So we use 6 negative 1 to find the c. So when y equal to negative 1, 1 over 2 x equal to 6 plus c. Therefore, negative 1 equal to 3 plus c. So c equivalent to 4. Therefore, y equal to 1 over 2x plus 4. Okay? Okay? Oh, sorry, minus 4. Negative 4. Negative 4. I'm sorry. Okay, so it passed through. So this is the equation of a blue line here. Okay? And then B. Find the two possible equation of the circle. Okay, so just now we have a circle. I just draw a large one. Okay, so what I know just now, this line, which is y equal to 1 over 2x plus, sorry, minus 4, pass through the center. Okay, so let's assume the coordinate here is x, y. So this particular point, when I substitute x inside, so my y will be this. All right. So let's say when x equal to 1, I got my y value, something like that. So what we can do, we just calculate this point I assume to be a, and the radius is 10. Okay. So my a coordinate will be 4, 3. So 4, 3. Okay, so the distance here will be 4, 3. I can use my distance formula where 4 minus x square plus negative 3 minus y square equivalent to 10 square, where my y is equivalent to this. You can use it. Okay, so it will be 4 minus x square plus is it negative 3 or positive 3? Positive 3, I'm sorry. So 3 minus 1 over 2x plus 4 square equivalent to 100. So x square minus 8x plus 16 plus, so 3 plus 4, 7. So 1 over 4x square plus minus 7x plus 49 equivalent to 100. Okay, so simplify, you'll get 5 over 4 x square minus 15x minus 35 equivalent to 0. Okay, so divide everything with 5 over 4, so you'll get x square minus 12x minus 28 equivalent to 0. So you can factorize this. So x minus 14 x plus 2 equivalent to 0. Okay, so x equal to 14, so x equal to negative 2. So when your x equal to 14, my y will be negative 2. When my x equal to negative 2, my y, sorry, when my x equal to 1 over 2 times 14 minus 4, 3. So y equal to 3. So when x equal to negative 2, my y equal to negative 5. Therefore, the two equation of the circle will be x minus 14 square plus y minus 3 square equivalent to 100, and another one will be x plus 2 square plus y plus 5 square equal to 100. Okay, because this will be your x and y respectively. Okay, now let's move on to the last question, question number 11. So for question number 11, the first question is quite straightforward and easy. So find dy dx and d square y over dx square in term of k. So we just directly differentiate. So first my dy over dx will be 1 over 2 kx negative 1 over 2 minus 8x, where my d square y over dx square will be negative 1 over 4 kx negative 3 over 2 minus 8. Okay, now it is given that k equal to 2. Find the coordinate of the stationary point and determine the nature. So coordinate of stationary point. So when they want to find the stationary point, we must know that my dy over dx equivalent to 0. Therefore, it's going to be my dy over dx equivalent to 1 over 2 k x negative 1 over 2 minus 8x. So 1. So x negative half minus 8x equal to 0. So x half negative half equal to 8x. So when you rearrange, so x power of 3 over 2 equal to 1 over 8. Okay. Therefore, x equal to 1 over 4. So you just remember this. I just bring 8 here and x here. So will be 1 over 8 equal to x times x power of half. Something like this. So I get x power of 3 over 2 and x 1 over 8. So x equal to uh, 1 over 4. Okay. And then when x equivalent to So when x equal to 1 over 4, so we find the d square. So just now d square y over dx square is equal to negative 1 over 4. My k is 2, x negative 3 over 2 minus 8. Okay, so will be negative 1 over 2, x negative 3 over 2 minus 8. When x equal to 1 over 4, my d square y is equal to negative 10. Okay, and coordinates, sorry. So since the question asks for coordinates, so we need to find the y value also. So when x equal to, so my y is equivalent to 2 sert x minus 4x plus 2. So when my x equal to 1 over 4, my y is equivalent to 2 sert 1 over 4 minus 4 1 over 4 plus 2. So my y is equivalent to square. So my y equivalent to 11 over 4. Okay. So the coordinate of the stationary point is 1 over 4 and 11 over 4. Okay. So since my d square y over dx square is smaller than 0, which is negative, therefore my coordinate 1 over 4, 11 over 4 is maximum point. And take note, if your d square take note, if your d square y over dx square less than 0, then it is a maximum point. If d square y over dx square is more than 0, then it's a minimum point. And if it is equivalent to 0, then point of inflection. Okay, so it's point of inflection. Okay, C. The point A and B is have x coordinate of 0.25 and 1 respectively. For different value of k, means another value of k, the Tangent to the curve at point A and point B meets with the x coordinate at point 6. Okay, find the value of k. Okay, so we just draw simple graph. Let's say this is my point A. Okay, and let's say this is my point B. A and point B. Okay, so at this point my x coordinate is 0.6. Okay, so what I'm going to do is now I'm going to find the equation of tangent to A. Okay, I will find the equation of tangent to A, and tangent to B, and then I will try to equate the both equation, and then we try to solve. Okay, first we find the equation of tangent at A. Equation of tangent at A. We attempt to find this first. So my dy over dx equal to 1 over 2 kx 1 over 2 negative minus 8x. Okay, so when x equal to 1 over 4, so 0.25, my dy over dx equal to so 1 over 2 k 1 over 4 power of negative half minus 8 1 over 4 will be k minus 2. Okay, so in order to find the y value for this when x equal to 1 over 4, I already find the no. So when x equal to 1 over 4, my y is equivalent to k 1 over 4 power of half minus 4 1 over 4 square plus 2. Am I correct? Yeah. Okay. So it's going to be y equal to 1 over 2k minus 2. Sorry, should be 7 over 4. Okay. So at equation of tangent A, so y equivalent to the gradient is k minus 2 mx plus c. So when x equal to 1 over 4, y equal to this, so we substitute. So 1 over 2k minus 7 over 4 equivalent to k minus 2 1 over 4 plus c. So 1 over 2k minus 7 over 4 equal to 1 over 4k minus 1 over 2 plus c. Okay, so we rearrange. My c will be c equal to 1 over 2k minus 1 over 4k minus 7 over 4 plus 1 over 2. Therefore, c equivalent to 1 over 4k plus 9 over 4. Okay, so this is the equation of tangent. So at A, the equation of tangent will be y equivalent to k minus 2x plus 1 over 4x plus 9 over 4. Okay, and 1 over 4k. Okay, now we do the same thing for B, tangent at B. So just now my dy over dx equal to 1 over 2 kx power of negative half minus 8x. So at b, x equal to 1, so my dy over dx equal to 1 over 2 k minus 8. Okay, so for y, so y equal to kx half minus 4x square plus 2. So when x equal to 1, my y will be k minus 2. Okay, so equation of tangent at B will be y equal to 1 over 2k minus 8x plus c. When x equal to 1, y equal to k minus 2. So k minus 2 equal to 1 over 2k minus 8 plus c. Therefore, c equal to k minus 1 over 2k minus 2 plus 8. Therefore, c will be 1 over 2k plus 6. Therefore, my equation of tangent at B will be y equivalent to 1 over 2k minus 8x plus 1 over 2k plus 6. So I continue at here, okay, since I don't have enough space. So y1 equal to y2. Therefore, my first equation k minus x. So y equal to k minus 2x plus 1 over 4 k minus 9 over 4 minus or plus. So this equation equivalent to 1 over 2 minus 8. Okay. So 1 over 2 k minus 8x 1 over 2 plus 6. 1 over 2 k plus 6. Okay. So and it's already given in the question that at this point my x coordinate is 0.6, so you can directly substitute in x equal to 0.6. So k minus 2 0.6 plus 1 over 4 k plus 9 over 4 equivalent to 1 over 2 k minus 8 x equal to 0.6 plus 1 over 2 k plus 6. Okay, so when you expand everything and rearrange, so you will get 0 negative 0.3 k minus 3.6 plus 0.25 k plus 3.75 equal to 0. So it's going to be negative 0.05k plus 0.15 equal to 0. So 0.055k equal to 0.15. Therefore, k equivalent to 3. Okay. So here for this question, you can use any other method. So what I did here is actually I find the equation of tangent at A, I find the equation of tangent at B, and then I equate both, and then I substitute x equal to 0.6 and find the k. That's what I did. So that's all from me. If you need any further clarification or any further questions you want me to highlight, so you can comment on the video. Thank you.